Welcome back, class. This is the lecture number 6 of electrochemistry, and we are approaching towards the end of this unit. I think in one or two lecture the unit will be complete. And if you think that we need to discuss a few topic, or if you have any query or any question, you can ask me in the comment box, or you can WhatsApp me. This is the lecture number 6, and the title of this is the activity and activity coefficient. Activity and activity coefficient. So first, let's start the discussion that what is activity. So activity, which is represented by A of an electrolyte, of an electrolyte is directly proportional to actual concentration. Whatever is the actual concentration, that is your the activity. So activity is directly proportional to C, and activity if equal, then it is gamma. This is gamma, and gamma is activity coefficient. So gamma is 1A upon C. So here A is the activity, C is the actual concentration, and gamma is the activity coefficient. Okay, but this is actually derived, this comes after several discussions, so we will discuss that thing, that how this concept is there, because before that we used to take concentration, normality, molarity, formality and all. What is the activity now? Okay, so for that, uh, as you know that the law of mass action, the law of mass action, what this law says, that rate of any reaction is equal to the product of active masses, equal to the product of active masses of reactant. So this is the law of mass action which we used earlier. For gases, in case of gas, what will happen? In case of gases, so gases, if you take, that is directly proportional to what? Partial pressure. Okay, and if the gas is ideal, if the gas is ideal, then the concentration is directly proportional to the pressure. This is according to the Henry law. You all remember that Henry's law. In for the ideal cases, concentration is directly proportional to pressure. So this is for the solid and this is for the gases, but what about the solution? So in case of solution, because concentration if you are talking, let's take an example. If you have a KCl in water, what happened with it? This is actually hydration. Okay, some amount of K ion and Cl ion will be hydrated with water. Some amount of, not the every amount. And if then we add silver nitrate in this solution, what will happen with that? Here we'll get AgCl precipitate with KNO3. So the formation of AgCl is actually the amount which is non solvated. See, if we have 100 molecule of KCl, got it? And in that 100 molecule, if the 75 molecule is non-solvated, with water, okay, with water, that means 25 molecule is solvated with water. So this 75 which is non-solvated, this is actually combined with this silver. This non-solvated molecule which uh, this non-solvated molecule will combine with the silver of silver nitrate, and this will give the precipitate of HCl. So the amount of AgCl formation, the amount of AgCl formation is equal to what? Is equal to amount of chloride ion which are non-solvated. Point to be noted. Which are not solvated. Okay. So this is formed because this is not solvated. There are some molecules which is not solvated, and these only the 75% will be able to combine by the Ag ion. That means what? Only that much of amount is capable to give AgCl. So the amount which is non-solvated is actually is your active mass. Point to be noted. The amount which is not solvated is actually active mass, and this active mass is called activity, which is called activity. So the activity is actually the non-solvated amount, because this is the activity, this is the only active. So what we can say that if we have C is the total concentration and A is the non-solvated, okay, so the ratio of A and C is called active fraction, or this is also called activity coefficient. Ratio of A and C, that means the non-solvated with total concentration is your activity coefficient. Okay, so in one line definition what we can say that amount of species present in a reaction which can react, which can react. This is the simplest definition. This is the activity. So A upon C equal to gamma. Gamma is the activity coefficient, which is we had already discussed here. A upon C is the activity coefficient, but it comes in this way. And for ideal solution, the activity coefficient will be 1. That means the activity is equal to the concentration. The activity is equals to concentration. Let's take any reaction example. We'll take, like, we have A, B, C, and D. Or if you take directly example like this, A plus B, C plus D. So the equilibrium, we know that the equilibrium K is written like that. Here in terms of activity, what we'll write, A into A, sorry, not A, is C. Equilibrium constant is found on that side. C D upon A into A B. And we know that activity is what? The concentration, and activity is gamma C also. Gamma is the activity coefficient, and C you can take any. If you are taking the molarity or normality, whatever you are taking, if you are taking the molality, suppose small m, so you will write like this, gamma C into gamma D upon gamma A, gamma B, and m can see that is a coefficient, and the molality D, then the molality A and molality B. So you are taking any, you can take here the normality also. If you will take the normality, this will look like this. If you take molarity, this will look like this. So you need to change only here. So this is very simple actually. Activity, it can be any, whereas in terms of concentration you have to mention the concentration, whether it is a molar concentration or normal concentration or molar concentration. But in case of activity, if you are mentioning the activity A, it means it is the concentration which takes part. Okay, it is the concentration, the actual concentration, whatever it is. It may be normal, it may be molar. So this is all about the lecture number 6, that is the activity and activity coefficient. In next that is the upcoming video is very important. We are going to discuss the Nernst equation along with some application on numerical, which is very important. And after that, I think within 1 or 2 lecture, your syllabus sorry, your unit, the electrochemistry third, will be complete. So thank you so much for your watching, and keep in touch. If you have any query, any doubt, any question, you can comment me in the comment box, or you can WhatsApp me to my WhatsApp number. Thank you so much.